Hello friends, welcome back. Hearty welcome to you. In the last session, we have seen a particular problem where we have to find out the equation of pair of lines intersecting at a particular point and parallel to the given pair. Now in this session, we will see the first bit, that is, we want to find out the equation of pair of lines intersecting at a particular point and perpendicular to the pair given. So first of all, before trying to find out how to know the equation, we'll try to derive the equation which will be perpendicular to the given pair and passing through a particular specific point. So once we are able to understand how the equation form will be, then we can easily do this particular problem. So let's take standard second degree homogeneous equation, which is ax square plus 2hxy plus by square equal to 0. Now we know that this can be written as combined equation of two straight lines by L1x plus M1y and multiply that with L2x plus M2y equal to 0. Let's multiply so that we can compare the coefficients. We'll have L1 L2 x square plus L1 M2 plus L2 M1 into xy plus M1 M2 y square is equal to 0. Now comparing the coefficients, ax square L1 L2 x square, by square M1 M2 y square, 2hxy L1 M2 plus L2 M1 into xy. By comparing them, we know that we will write down here, we know a equal to L1 L2, 2h equal to L1 M2 plus L2 M1 and b equal to M1 M2. So we know that. Now this is what we know by comparing the coefficients. So let me just write down. So this is what we know, which we will use at the end. Now let's take each line and try to find out the perpendiculars to this particular line perpendicular to the given lines and passing through a point, specific point like 2 minus 1. Let us say passing through point x1 comma y1. So let's try to find out that. Let's try to find out the lines perpendicular to the two different lines. First we'll write down, we want a line which is perpendicular to L1x plus M1y equal to 0. It should also pass through the point x1 comma y1. Similarly, we want a line which is perpendicular to L2x plus M2y equal to 0. It should also pass through the point x1 comma y1. Now we know that any line perpendicular to this line will have coefficients switched with a sign, opposite sign, because the slopes product is minus 1. Can I write down that as M1x minus L1y plus k is equal to 0. I can find out the value of k by substituting x and y as x1 comma y1. It will become M1 x1 minus L1 y1 plus k is equal to 0, or can I say k equal to L1 y1 minus M1 x1. Now can I go back and substitute whatever the k value I got in this particular equation? I will have my next step is, so the equation of the line will be M1x minus M1 x1 minus L1y plus L1 y1 is equal to 0. Now that's the equation of the line. So let's try to simplify that. Can we simplify that? Let us see. So if we simplify, that's nothing but equal to M1 into x minus x1 minus of L1 into y minus y1 is equal to 0. this is the first equation of the line which is perpendicular to the L1x plus M1y equal to 0 and passing through x1 comma y1. The same logic we can apply on the other side also. Our equation will be M2 into x minus x1 minus of L2 into y minus y1 equal to 0. Now this is our second equation. So we have two equations now. We can go back and multiply them so that we can represent them back in the pair of straight lines format. So that will be our next step. The combined equation will be M1 into x minus x1 minus L1 into y minus y1. I have to multiply with M2 into x minus x1 minus L2 into y minus y1. Now let's multiply that. We will have M1 M2 into x minus x1 whole square. Then afterwards, what we see now, we did this first into first, we do first into last, and also these two we add them. We see that x minus x1 y minus y1 can be taken common, so it will be nothing but minus of L1 M2 plus L2 M1 into x minus x1 into y minus y1, and last step we have is plus L1 L2 y minus y1 whole square. So this is nothing but equal to, we go back and compare, M1 M2 is b, so I can write b into x minus x1 whole square minus 2h, because L1 M2 plus L2 M1 is 2h, into x minus x1 into y minus y1 plus L1 L2 is a, so I can say a into y minus y1 whole square is equal to 0. So that's a equation of the pair of straight lines perpendicular to the given second degree homogeneous equation and passing through a point. Now this formula, whatever we got now, we can substitute for this given equation pair of straight lines. We also know the point, we can substitute and we should be able to get the equation of the pair of lines. Now let's go to our original problem and try to find out the equation of pair of lines perpendicular to 6x square minus 13xy minus 5y square equal to 0 and intersecting at a point 2 comma minus 1. So I'll write down here 6x square minus 13xy minus 5y square is equal to 0. Point is 2 comma minus 1. Let's write down the values. We have a equal to 6, 2h equal to minus 13, b equal to minus 5, x1 is 2, y1 is minus 1. Let's substitute in the formula whatever we have. b into x minus x1 whole square, so minus 5 into x minus x1 x minus 2 whole square minus 2h, minus of minus is plus, can I say 13 into x minus x1 x minus 2 into y minus y1, y1 is minus 1, so it will become plus 1. Afterwards I have plus a, that is 6 into y minus y1 whole square, that is y plus 1 whole square equal to 0. Let's multiply with minus so that we can make it easy. Next step will be 5 into x minus 2 whole square minus 13 into x minus 2 into y plus 1 minus 6 into y plus 1 whole square equal to 0. Now let's open the brackets here. We have 5 into x square minus 4x plus 4 minus 13 into xy plus x minus 2y minus 2 minus 6 into y square plus 2y plus 1 equal to 0. Let's simplify that. This will be our final step. First we'll multiply 5 into x square. 5x square will be there. Then 13 into xy will give me minus 13xy. Afterwards minus 6 into y square will give me minus 6y square. Let's go to x now. I have x term here and x term here. So minus 20x minus 13x, that's nothing but minus 33x. Then let's go to y terms. Y terms are, I have here one y term and here one y term. This is 26y and this is 12. This is 26y and this is minus 12y. So it will become plus 14y. Then let's go to constant terms. We have 5 4s are 20, plus 13 into 2 is 26, 20 plus 26 is 46, minus 6, that's nothing but plus 40. I skipped a couple of steps, but you should be okay with that. You can simplify that slowly within 2 steps, but the final answer will be 5x square minus 13xy minus 6y square minus 33x plus 14y plus 40 equal to 0. So let's summarize. In this session we have seen how to find out the equation of pair of lines given to the given pair of lines. We want to find out the equation of pair of lines which is perpendicular to the given pair and also they are intersecting at a particular point. So we derived the formula and we have leveraged the formula, substituted the values, we are able to get the equation of pair of lines.